Welcome back. Today we're going over BlazingText, but before we get started, hit the like button, subscribe, or share this with anyone you know taking the AWS Machine Learning Associate exam. So, BlazingText, fast NLP for text classification and word embeddings. Natural language processing challenges organizations with a fundamental paradox. Text data is abundant and valuable, yet extracting actionable insights requires sophisticated algorithms operating at scale. Traditional NLP approaches struggle with the computational demands of processing millions of documents, while custom deep learning implementations require expertise many teams lack. BlazingText addresses this gap through optimized implementations of two proven NLP techniques: supervised text classification for categorizing sequences into predefined classes, and word2vec for learning semantic word relationships through unsupervised embedding generation. The algorithm's name reflects its engineering focus, achieving exceptional processing speed through hardware acceleration and algorithmic optimizations. All right. So there's a dual mode architecture for NLP tasks. BlazingText operates in two distinct modes, each addressing different NLP requirements with specialized implementations optimized for their specific challenges. You have text classification mode, which implements supervised learning for sentence categorization. Organizations use this for customer support ticket routing, spam detection, sentiment analysis, and document organization. The algorithm learns from labeling, training examples. It also builds models that predict categories for new sentences based on learned patterns. Then you have word2vec, that's VEC, right? This mode implements unsupervised learning to generate word embeddings, dense vector representations that capture semantic relationships between words. These embeddings enable downstream NLP tasks by transforming words into numeric vectors where semantic similarity manifests as geometric proximity. Words with similar meanings cluster together in the embedding space, enabling similarity calculations, analogy detection, and improved feature representations for other models. So let's go into word2vec. All right. So word2vec offers three distinct implementations. Each balances performance characteristics differently to address varying scale requirements. First is CBOW. This is continuous bag of words. So this predicts target words from surrounding context words, ignoring word order while focusing on semantic patterns. This implementation operates efficiently on single nodes, making it suitable for moderate scale embedding generation where distributed training isn't required. Then you have skipgram. This learns by predicting context words from target words, respecting word order, and capturing more nuanced relationships. Like CBOW, skipgram operates on single nodes, but often produces higher quality embeddings for smaller vocabularies. Then you have batch skipgram. This extends skipgram's capabilities through the distributed training across multiple CPU nodes. This implementation transforms standard skipgrams level 1 BLAS operations into level 3 BLAS operations through mini batching. This enables efficient parallelization that scales horizontally with dataset size. So what's some data prep? All right. So BlazingText demands specific input formats that reflect its optimization focus. For text classification, each training sequence must begin with a label indicator, like a label and then a category, followed by space-separated tokens. So you can have label positive to produce a product that exceeds expectations, and a label negative so that you can show that this was a disappointing situation. Pre-processing requirements include lowercase conversion, space-separated tokenization, and punctuation treatment as separate tokens. These formatting conventions enable BlazingText's efficient parsing and processing pipelines. Word2vec mode requires simpler formatting, one sentence per line with space-separated tokens with no label requirements. The algorithm learns embeddings purely from word concurrence patterns in the provided text corpus. All right, so let's do a little hands-on. All right, let's go to the console, see where we are. See SageMaker. All right. Training jobs, create a training job. Okay. blazing text test, right? This is what we'll set. Choose a built-in algorithm, which is pre-selected. And object to vec, that's one. Blazing text, text classification, and text embedding. That's the other, all right? So this will configure the optimized training container with the necessary NLP frameworks for BlazingText, right? So you see the file or pipe method, right? File is going to download it to your machine and then process it. Pipe will go straight from S3 in there, okay? Next, you're going to select your instance type. You really want to go for CPU. GPU is going to cost more, but CPU is what it's optimized for. So you choose instances based on mode, model, and data scale. CPU, CBOW or skipgram will work with word to vec with small data sets. So an ML instance can work. A GPU will be fast training. So that'll be good for batch skipgram distributed training. And then you can use like the MLC, right? So these will be the compute and GPU optimized, right? And these will have horizontal scaling. And then for text classifications, these will also be good as well. Larger ones will be suitable for the P size over here, right? Remember, costs go up as an instance's size and compute capabilities increase, but it also offers you faster completion. Right, so we'll just stick with the ML large because we're not going to actually make this, right? Your keeper live period, set that for, let's say, 60 minutes, right? Encryption, this is to encrypt your data, right? Make sure that nothing is able. Isolation via network, the default is selected here, but you should have your own VPC that's outside of the default, obviously, if you're in your organization. Okay, and then your hyperparameters, right? So mode. So this is where you can set your mode to the specific operation type, right? Skipgram, CBOW, batch skipgram, supervised, right? Supervised is for text classification. CBOW, skipgram, batch skipgram are for word to vec, right? Which we talked about earlier, right? So we'll just keep it on skipgram. Epochs, these will be your training iterations. So you'll have 5 of them. Your learning iteration. Oh, do I not see it? Oh, your learning rate, sorry. Learning rate, this is your gradient step size, right? Then your vector, all right? This is how much your embedding, how many dimensions your embeddings have. And then your word n-grams will be adjacent word considerations, okay? So for word to vec, if you selected that, one of these 3, right? Then you adjust vector dim, all right, for the embedding size. And then your window size, which is here, all right? Then you adjust your context window. And then you have your negative samples to adjust your training control, all right? And at that point, you go down, name your channel, your input mode, pipe or file. We have file up top. Select your content, text. See, text plain. All right. Compression, that's obviously for saving space and your transfer costs. And then you set your S3 location based off of your buckets, that you would see here, okay? And your checkpoints are basically your saved points so that you can restart, or you can do a local path, and then you have your output. All right. And from there, you launch a training job, you monitor progress through the CloudWatch logs or the SageMaker dashboard, and then BlazingText optimization will result in, training that is pretty fast compared to traditional implementations. And the completion time will be somewhere between minutes for moderate sets to hours for massive data sets. All right. And then from here, you'll be able to have a batch transformation for offline processing, for large documentations, and you shouldn't have persistent endpoint costs. You would create this by clicking Create Training Job. Click off of that. Okay, so cost optimizations. All right, so pricing. So BlazingText efficiency reduces training costs through faster completion times, but instant selection significantly impacts the total spending. GPUs can accelerate training, but cost more. They cost more than CPUs, right? Evaluate whether reduced training time justifies a higher hourly rate for your specific workload. For word-to-vec distributed training, batch skipgram mode enables using multiple CPUs rather than expensive GPU hardware. So it provides better cost performance for large vocabulary embedding generations. So consider batch transformation for inference scenarios where real-time predictions aren't required. Avoid ongoing endpoint costs while still processing a large document volume efficiently. So that's the purpose of BlazingText, right? It represents a practical NLP for real-world deployment constraints, right? If you focus on the techniques that we've gone over, and then you focus on operational efficiency, you'll be able to have your organization deploy text classification and word embeddings at scale without requiring deep NLP expertise or extensive and expensive computational resources. And that's all we have for BlazingText. Thank you for joining us. Remember to hit the like button, subscribe, or share with anyone you know taking the AWS Machine Learning Associate exam. Thank you. Have a good day.